Okay, welcome to part 5 of the Slapdown intake series. Remember that we made the half stop, we made this part here, and also the sprockets faced up, and we started assembling everything. So now we're just going to finish off with the assembly. So I guess I can put in another plate. Let's see if I can do it with a fasten. Looks good. I'll put in one of these guys, and that can be fastened to this. I will have to redo this once I've pocketed it and reduce the number of holes, but for now it's just going to be like this. And I'm going to do some sprocket stuff. So, what I'll do actually is extend this out. What was it before? So that was 35 away from the face. This one is 3. So I'll bring it in by about 32, and I can do that by changing the length of this roller. Change configuration, 732. That's what we want. Yeah, you can see now it's 3mm. Perfect. And I'll do the same thing for the other 2 rollers. Change config, 732. Change config. Oops. 732. Awesome. Now I'll do the same thing with the sprocket that I did before. So I'm going to copy this, and I'm going to copy this, and I guess I can also grab the bearing as well. I won't do the hex shaft, I'll do that later. But now that I've copied all of those 3, the mates that relate each other stick, so that I don't have to redo those. And I'll fasten him to him, flip that around to solve. Perfect, that's exactly what I wanted. Put the second bearing in the other side. Fasten again, this to this, flip. Yep. And I'll grab this configurable shaft. And I'll do the exact same thing. So what did we do before? Oh right, we will show the mate connectors. Whoa. Is there a button to show mate connectors? I don't know if there is one. Surely. No, I don't know. Okay, doesn't matter. Fasten mate. That to the inside of this. Yep. Wait. Oh no, that's not right. Because actually what I wanted was that mate needs to be to the washer. Right. So I want this. No, not that one. Dang it. Delete that. What I want is that one there. Yeah. You can see the circlet's right up against the bearing now, which is what we want. That's a circlet. Grab the bolt. Again. Fasten. Something I should mention, that a really nice thing about the rollers is this hex shaft acts as something that holds the intake plates together. Usually we have like standoffs on the outside, but when you have a dead roller, you can use the inside of the roller for your standoffs. So it looks kind of clean. Next thing I'll do, put the shaft that runs all the way along. Actually, I'll add the bearing in here. And now I'm going to get the shaft that runs all the way along. So I can measure that out, figure out just how long this shaft needs to be. So it needs to be that long. And I will go CAD. I'm going to go to my favorites, 1/2 inch shaft, millimeters, snap ring, insert. Snap ring is just a circlip. So yeah, it's already made me a make connector where I want it. So that is going to sit like there. Yeah, like that. And I'm going to hide that make connector. Hide all make connectors. Hey. Then I'll grab another one of those sprockets, because you know, you could rely on the rollers and this hex shaft to, you know, when this swings out, the rollers and the hex shafts will mean that this plate also swings out, but that could lead to some pretty bad twisting between the two sides. So if we drive both sides via this hex shaft, we can kind of like avoid that, right? Now, yeah, we'll talk about like the position of the hex shaft later, but right now the hex shafts might kind of like be in the way of a ball that's coming through. So you might want to like not position it vertically, but rather like these two bearings are going to be horizontal to each other. Yeah, just to get the hex shaft a bit lower. That's why we make CAD that's easy to change, so that we can fix that up if we want to. So those two faces. And I'm going to do a slider. So, okay, now I could put like a very long spacer here, but I don't really want to. I don't really think this kind of plate is necessary here. I don't see this hex shaft kind of like bending in just from the chain. So what I'll do is I'm just going to put a collar. Now collars are a bit dangerous. Collars, the way that they work is, let's say we use something like this, right? But the way that collars work is you use this bolt to like clamp down on it, on the hex shaft, so that it like can't move due to friction. But the issue with that is if that bolt backs out, that collar is going to move, which is going to let this sprocket move, which is not the end of the world, but if we use one of these, we just need to make sure that it's Loctited, which is like a adhesive glue. It's a glue for thread. Quick little tip, if you're struggling to like pick the right main connector and you can see that it's like got this grey cross on it, you can hold down shift, which will kind of like lock it, and then hover over to the one you want. So then I will put that, see, again, shift, put that there, flip that. Yeah, just like that. Yeah. So now, what I might do is, I'm kind of skeptical that like inside of here, there's a bolt that like fits, because the bolt needs to fit in between these two plates. So what I'm going to do is I'm going to insert standard content. I'll click right here, and no, actually I'll do all of them actually. I think this should work. Auto size, select. Can I put it in multiple? And then I can insert like that. Let it load. So yeah, and we can see it does clear, which is good. That's great. You might have issues of it like bending and it hitting. So you might want to bring it in a bit, but I'm just going to leave it for now because I don't want to spend too long playing around with it. That's something that we should catch in some kind of like design review. But if it does rub, it's not the end of the world. It's just rubbing against the plate, but it's not optimal because it's friction you don't want. Yeah. So now, what I'll do is I can draw up this spacer here. So we're going to have a 20mm nylon spacer, favorites, nylon spacer. It's going to have an ID of 5.1. It's going to have an ID of 10mm, sorry, it's going to be inches, millimeters, sorry, and it's going to be 20 or 1. So I'm going to insert that. Fasten, yeah, to that, flip that. Also, that's not necessarily made out of nylon. Just because it says nylon spacer doesn't mean we have to make it out of nylon. It could be made out of like acetal or aluminium. I don't know. Oh, right, we need to update our plate because remember we made our master sketch and we changed our master sketch and we versioned it. So you can see it's got this blue thing. So I'm gonna update. Should move some of the points. Looks a bit weird, but that's okay. Why is it still blue? Okay, stop being blue. Yeah. You can see that. Remember how we did the? We made sure that the roller was always bigger than this perimeter. So that's great. We like that. Okie dokie. Let's draw the chain, and we draw the chain just to make sure that nothing is going to hit the chain. That gear might hit the chain, that plate might hit the chain. So I'm gonna open up. Is that the right one? Oh, I don't remember saving the chain recalc. Oh, okay, not fun. That's okay. I don't really need it. I just need to know. But it is great to save it because, if I want to move this pivot point, I kind of need that chain recalc so I can adjust this length. I just need to know that. Sorry. 192.818. So I can go chain. Scroll down. Chain configurable. I might just hide that. I've got an 18 to a 36. 192 point, what was it? 0.18? I don't remember. I'll have a look. Millimeters. Let that load before I move and check. Okay, so that's generated. Now I'll go into here. Oh yeah, perfect. Then I can say, okay, I want to fasten this to the middle of this guy. So that looks good. And I'm just going to position this roughly. I don't really care if it's precise. Oh wait, I did the fasten. Dang it. I want Revolut. Then I can adjust him. And you can see that chain clears. So I'm happy with that. I could even shorten this guy so that the chain is right up against this plate. But yeah. Sick. Let's do the belts. Let's fix the belts actually, because currently we have 12 to 24 and then 24s, but we had 18 before, which is not entirely correct. So let's go to our master sketch. and actually we'll do the first one first, the motor one, which isn't actually in our master sketch, it's in here, and we should have saved the recalc, but we didn't. So open up that sketch, recalc, belt calculator. We're gonna have a target center of around 155 millimeters. The number of teeth is gonna be 12. Let's go to a 36. Just 2 to 1's a bit quick. 3 to 1 is probably a bit safer. So we can do a 151 or we can do a 163. Let's do a 151. Yeah. What I'll do as well is I'm going to draw the pitch diameters of all the sprockets, so that we can use some kind of like belt script where you select the pitch diameters and it generates the belts for you. So do that. This, oh wait, I've got to find out what the pitch diameter actually is. Pulley. Go to the drawings. So the pitch diameter of a 12 tooth of a HDD 5mm is 19.1mm. Oops. 19.1. So that's the inner one there. This one is going to be a 36. Yeah, we've got the table right. This one's going to be a 36, so here's going to be a 57. 57.3. This one is going to be 24, and so is this one, so we'll make them equal. Oh, and I also need a 24 here. Make those two equal. That on the construction. Replace that to be there. 38.2 is the pitch diameter. Yeah. So I'm gonna go and copy this link, chuck it in here, create a new comment, mark up that line. Yeah. Okay. Then I can go back into my assembly and I can modify, I need to modify this to be 36 because I just said that it was going to be 36. The left one needs to be 36. That goes to bigger one, so on. Oh, and yeah, I'm going to need to go into my master sketch and change those distances to be correct. Yeah, that looks good. So I'll go into my master sketch, timed out, okay. And I'm going to open up this one first. So I've got a 24 to a 24. Now my new center distance is super easy to change. You can see how easy it is. So I had, what did I have before? I had 105, right? 105. So in millimeters. I suppose I'll just go to this one. 1025. And I'm going to edit this to be the new one. Same deal here. 24 to 24. My target center is 142.5. 142.5. And yeah, so you can go here and find out what the pitch diameters of your pulleys are. But anyway, 140. Awesome. And I'll edit this guy to also be 140. Save. version him. Yep. And I'm going to update him in here. Should move things around a little bit. Perfect. Yep. Okay. So now I'm going to generate the belts. So the way I do that, I've got this belt calculator. I will show you how to do that. So, Joshua Wang's feature scripts. Okay, so I'll leave the Joshua Wang feature script in the description, but the way that you can add it is you go add custom features, paste the URL, search, and then you just click on that, right? Then I think you somehow add it. Yeah, oh, it was removed. Added. Perfect, that's what I want. So what I'll do is I'll unhide, not this one, I'll unhide this, right? And I'm going to start drawing up the belts. So I'm going to do it on this side. Belt. So the reference plane, I guess it could be that. And now the guides, which are the pitch diameters to the belt. So I'll pick the little one to the big one. That's my 12 to 36. Tick. Okay. Then I want my 24 to my other 24. Oops. Actually, I'm going to redo the order so that them, yeah, whatever. Yeah. Made it there. And then I'm going to do my last one, which is this one to this one. So yeah, those are my 3 belts that I'll be using. Which ones did I select? I wanted to select this one and this one. Yeah, just like that. You can also do that with the chain. There's, you've got 2 options on how to make chain, but there's no belt part in MKCAD. So you kind of have to use that script to just make it yourself, which honestly isn't too bad. But this way was really, really easy. So I've got that one. And that's going to be fastened. I'll fasten that to that. Yeah. I'll set that a little bit. 5 mil maybe? No, maybe 5 is way too much. It's okay. I mean, like, it's fine. You can see that it's obviously going to fit. Put the next one in. I think the short one is the next one. 65, yeah. And I will go fasten that to this. Yes. And the next one. The long one. It's the next one. Hold down shift. Same with this one. Oh. Sick. That's that, right? What else can I do? I can move this chain over here as well, so that I have it in both places. Fasten this to this, right? Just like that. Those two faces parallel? No, they're not. That's kind of weird. I think I did my planar wrong. Yeah, I've made these. Yeah, I need to do that. Okay. Sick. That looks good. What else can we do? Before we talk about other stuff. Oh, I can put my hard stop. In. So the hard stop sits. That one gets bolted onto here. Not quite. I'll make that revolute. And this one to this one. Yeah, like that. And I'm missing out on anything? I don't think so. Like, you can add bolts if you think it's going to hit something. I suppose I can put this spacer in as well, from there to there. 18.29 spacer, length 18.29 millimeters. Could also put one in here. Hello? Please? God damn it, Onshape. Okay. What? Can I have a make connector? Okay. Thanks. That one can go there. Flip it. Yeah. So that's kind of how you do it. Alright, let's talk about now our general design. So the first thing I want to point out is this is still unpocketed because we need to play around with the geometries of things, see what we're happy with. Currently, if the ball was going to come in and we had like a long hex shaft going all the way around here, the ball's going to hit the hex shaft and it's kind of going to get in the way. So ideally you'd actually have that hex shaft that goes all the way along. Why? Because if this plate starts bending in, if it starts bending in, let me show you. If it starts bending in this way, because this is called a cantilever, where you've got your bolt supported by one edge here. If it starts bending in, that could bend the bolt, and that's not something that we want. So that hex shaft is going to help greatly to get rid of that cantilever if we have a hex shaft running all the way along here. But currently it's in the way. That's why that's why I have it as like two short stubs. Now what you can do to deal with that is you can just move the pivot point, and we can move the pivot point right up against the bumpers, pretty much. So let's actually go ahead and do that. Yeah, let's go ahead and do that because of things. So let's bring this in by 20 mil, and let's bring this down by 20 mil, and we'll make a version. Yeah, well, you still have to change the angle for the hard stop. Let's update that. Did that move? I don't know. Oh yeah, it did. You can see that now, like, this part is hitting the swerve. But it didn't move forward, right? and it did move lower. Though I kind of want that shaft to be, let's say I want it to be like a little bit lower than the bumpers. So I'm going to go back into my sketch. I can see that it's not lower than the bumpers here. So I can bring it down to 130 maybe. Now, just keep in mind that like you can't be too excessive with your pivot changes. At some point you might break something, but this whole like method of sketching does give you quite a lot of freedom over modifying things. So hopefully this doesn't break anything. Yeah, now we're considerably lower than our bumpers. An issue is obviously like now our position. Oh, see something's broken. Like I said. What is this? Oh, wait. What is that even supposed to be? That's supposed to be that circle? That's so strange that it's not doing the right thing. Yeah, whack. Okay. No worries. That broke. Fix that. Yeah, I forgot what I was saying. But you know, things will start to break. You can see here, like, okay, this is something I actually did wrong. I shouldn't have constrained it to like that. What I should have done is so where is this guy? Yep. I should delete this, and I should constrain like the holes of the plates together so that they move together. Hide. Can I make it transparent? Yeah. Whatever. And I'll make it like, I'll make it a slider mate so that it can still. No, I'll make it a. Wait. What? It's not right. So what I have now, I have this that can move around, right? And I should have constrained plates together. So I'll make this and this. Oh, I see. Like that. And I'm gonna drag this guy out, and I'm gonna make him planar to there. Solve. Perfect. Now I can move stuff around, no problem. But you can see, like, now I'm hitting the chain there. I'm gonna want to bring it out a bit. Also, I'm hitting here. That's not great. But what I should be doing as well is I'm not gonna do it in this video, but I should kind of like design my intake to follow this contour, so that the bumper gets used as a hard stop. And what I can do though is I need to change this angle. How much time? 36, 81, 852. 81, 852. So I can go click on here. 81.852. Right. So now, if I go here, it should update so that it's still kind of like. Oh, it's because my Revolute, this Revolute here, needs 81.852. Right. And now that should come down and hit the hard stop. Perfect. Yeah. Now I can, for example, put a shaft all the way along that kind of like clears the swerve drive, which is great. Though the swerve drive, I just did it based off like this, but the swerve drive we have has like covers, so it probably won't clear. What else can I mention before I wrap up this video? Oh, let's you know what, I'll do the next one. In the next one, what we'll do, really the last one, is actually no, sorry. what we'll do now is we'll change the chain to be correct. So I'm going to go to recalc, go back to the chain calculator. I need to reconstruct this because I forgot to save it. Like that, 192.818. 192.818. Teeth, 18 to 36. But I want it to be a bit longer, right? So what I actually want is something like maybe 200 gonna work, or is that not enough? No, 220. Yeah, 220 is alright. So I'm gonna go into here, 220. Yeah, I'll grab that number. And I won't forget to copy that and put that in here. I do need to change my chain distance though. You can see it's too short. So, change config. Give it the recalc link. Tick. So yeah, there you have it. You could assemble that. It'll work, right? But yeah, we still need to work on our pocketing of our plate. And yeah, thanks for watching. In the next one, we'll be working on pocketing this plate, these two plates, and fixing up their size because I'm not really a fan of this, for example. Yeah, thanks for watching. Bye.